All right, welcome back. With this week's lesson, we're going to talk about spatial visualization using the ArcGIS API for Python. We've already seen why visualization is important, especially when it comes to uh, tabular data, such as Excel spreadsheets, information that maybe contains information about housing prices, stuff like that. Now we're going to look at how we can take those same principles that we learned earlier and apply it to spatial visualization or geospatial information more specifically. And the ArcGIS API for Python has what's built into it, which is called a mapping widget. And there's also web maps and web scenes. We're going to focus mainly on the two-dimensional space, so a flat map that you would maybe print out or see within a JavaScript application, even though they can be 3D based. So the ArcGIS API for Python has a mapping module, and it would be arcgis.mapping, and then there's a web map class. Off the GIS object, there's a method called map, and you can also pass in information there, and we'll show that in a minute. Each map has a various set of properties, and these properties allow you to control the zoom, the center, the base map that's shown, and whether it's in 2D or 3D mode. We can add layers, items, we can add by URL, imagery layers, we can remove, we can draw graphics on the map, and then we can persist it out to save it. Now, when you create a map off the get-go, you should know that this map won't persist anywhere. So if you're not connected to an enterprise, you're connected anonymously, you're going to be able to still draw information and consume it. There's a function off of there called save that's going to allow you to persist it to your enterprise or ArcGIS Online. Let's get started and see how we create this. So I'm going to go ahead and I'm going to do from arcgis.gis import GIS. And then we're going to instantiate a GIS object that's an anonymous connection that'll connect to ArcGIS Online. I'm going to create a variable m, assign it, and then create a map. So I do gis.map, and notice I put in an address here. In this case, it's going to be a city in Germany, so Frankfurt, Germany, and then I do m. And what m's going to do is it's going to go ahead and in the Jupyter Notebook environment, it's actually going to render a web map for us. So it's doing our import, it's connecting to the anonymous connection, and then we see this JavaScript application appear. Now, notice that it geocodes to the full extent of the city, so we have Frankfurt, Germany, right in front of us, and it uses the world geocoder by default. If you were to connect to the GIS and data organization, so the Johns Hopkins information, the default geocoder for that organization is actually a Maryland geocoder. That means that you're going to have to specify what geocoder you want to use first before you use the map. So Frankfurt, Germany wouldn't work in this case. You would have to put a location within Maryland or say, I want to use the world geocoder. And you can understand how this is going to work. Let's take a look. So I'm going to create a new cell below and do gis.map, and we're going to use that question mark syntax. That'll give us that rich help. And notice there's a variable called geocoder. And this allows you to specify an optional geocoder. So when you're using the widget with the Johns Hopkins specifically organization, because the world geocoder is not the default, you want to specify world geocoder for any areas that are outside the Maryland region. Okay. So now we have our interactive web map, and we can do things like set zoom levels. And what zoom level will map to is the cache levels that are predefined. And in this case, we're zoomed at default to level 10. But I could set it to level 15, and we'll see that we zoomed out. And if we go back and we look at our zoom, it'll say that it's 15. We can do some other interesting things, so let's rotate it. So I'm going to set this timer a little higher. Instead of 1 second, I'm going to say 3. And we can rotate it just like you would rotate a piece of paper. So I'm going to do 45, 90, 180, 270, and then back to 0 or 360. So let's go up and we can take a look at the map. And we can see that it's changed and it changed again. And we'll see every time it'll go around. Now we're completely upside down. One more and we should be back to the original. There we go. So we're back. So we just did a little circle of the various areas that went through. It's pretty neat. So let's create the next thing we're going to talk about is we can look at rotations and and base maps. And base maps are the underlying background data that we have, and these are usually either cached tile maps or cache vector base maps. Base maps with an S provides us a full list of available default base maps that are built into the JavaScript API. And then we get and set our base map on the property called base map without an S. Let's see how that works. So I'm going to create an area over top of Paris. Once again, I'm still using that anonymous connection, so I didn't have to pass in that geocoder. So here we have Paris, and we can see it has the default base map that comes with the that's set on the JavaScript API. So from our map and then our map view. Now we can go ahead and we can look at the various base maps. And we can see that I'm going to start at the first one, go to the last one, and my step size is going to be 2. So I'm not going to look at every base map, and it's going to update the map above. And I'm just going to do my map m1.basemap equals the base map name. And I'm also going to print it out and then have a little pause. So hopefully it'll come through and see that there's a whole bunch of options. So let's go ahead and do that. So we have our default, the gray, etc. And you can see the various updates as we go through. And then we ended on terrain. Okay, so that's a general idea. And what you would do is if you were going to use a default base map that was set up by Esri, you could just go through and maybe put all your information in and then see the best one that matches how your data is symbolized by default. Another interesting thing that we can do is that we can have our data in 3D. So we can do 3D visualization. So I'm going to go ahead and create my web map. And in this case, notice I'm going to set mode equal to 3D. And you really can't tell here, but as I zoom out, you'll notice that it's a globe. And then when I zoom back in, it sort of gets that 2D feel. But you can start your data and display three-dimensional data in that faux 2.5 effect for 3D. So let's go ahead and add some content. So in this case, I'm going to look for data within Europe that's owned by Esri Germany. And I want it to be feature layers. And we can see we get a whole bunch of information. We're going to go ahead and add an item, and we're going to focus in on the Netherlands. So just taking that search result we had before, which is our list, we're just going to say we want the first item in our list and add it to our map. And you see we get our polygons here all show up as expected. And we can go ahead and we can even add additional information. So this one is a hill shade effect for the Netherlands. So this is an image layer. And we can stack our information on top of each other. And think of it as a stack of plates. So the last thing you add goes on top, and each other layer goes below it. So below this image layer is actually our original polygon layer, which was this demographics layer that we had. To remove all the layers, we just do our map object dot remove layers, and we don't pass in any information. Let's do it again, and we're going to add information a different way. So we saw adding information by item. We're going to go to that same Netherlands area that we had before, and we can see that we have 0 layers, or we can see that our item has 1 layer. If we had an item that wasn't registered with server, this is how we'd go ahead and add it. So we would just take our layer and just pass it into add layers. So notice it's the same process to add this information in, just like we did before, but instead of passing in an item, we're actually passing in this layer object right here. And we can do other things like adding spatially enabled data frames. Here, I'm going to go ahead and I'm going to query some content. It's going to return it back as a spatially enabled data frame. And this gives us that pandas data frame that we had before, except we have that shape column. We can add this information either to a new web map by doing sdf.spatial.plot, or we could pass in this map widget. So I could say map widget 4 and pass it in here. And it'll draw the information directly on this map widget once it renders. We get back our true. Let's zoom out, and we can see we have our point data for all the major cities within the world, along with all the properties. Pretty neat. Let's take a look at some other ways. So what we've seen so far was just accepting predefined geometries, predefined symbologies, and letting the system choose it for us. But let's say we want to be a little more exact with the way we look at information. So we can take advantage of the full smart mapping capabilities within the JavaScript API. And these are algorithms that were written on the back end to visualize data the best that it can based on the information provided. So for example, let's say we want to render the width of lines on a specific field. In this case, we want to render the width of the line based on the distance miles. So I'm going to go ahead, center my map to where I want it to be, add a layer item, and then this will allow me to override the default symbology that was set on the USA freeway system. So let's go ahead and do that. So just recenter my map, and now it's going to go ahead and draw this. And we can see that the lines are a lot wider than would be expected because we're saying, hey, I want the width of these lines based on this class size renderer to be proportional to the distance of the total road. And as I zoom in and out, you'll see that the lines actually adjust based on the zoom and the extent of what you're looking at your data. We can visualize more than just points and line data like we've seen already. We can also look at Polygon data. So here we're going to use the add layers, and we're going to say we have this feature layer with the URL, and we're going to set a definition expression. So we're going to limit our content for the whole United States just to the state of Washington. We're going to say we want to do a class break color render on this field, and then we want to set the opacity, or how transparent it is, to 0.7. So let's go ahead and add that and see what happens. Here we get our class break renders shown here for the Polygon data. And we could do something like this, and we could say m6.legend equals true. And now we know the exact breaks of how these counties are being broken up for the state of Washington. I could then save this information out and persist it out to a web map, and all that symbology will follow with it. We can do advanced cartography using Arcade, and we can do things like comparing value A to value B. So we're going to compare. So I'm going to go ahead and I'm going to create my map, and then I'm going to say, hey, I'm going to take advantage of the JavaScript autocasting, and I want to do class breaks on my pop25 field, set my transparency. So notice this time, instead of setting it to a decimal place, we're actually using the whole percentage value. So it's pretty adaptive that way when we use autocasting. We're going to set the min value to be something very small, and then we're going to create our visual variable. For the visual variable that we're using a color info, setting our field, defining our stops, as defined here with our colors. These are RGBA, so this is red, green, blue, and then alpha, which is transparency, and defining labels as well. And then we're also going to use a class break info, sort of what we have, just like what we had before with the polygons, except in this case, we're setting our max value and some other information. Going to create a feature layer and then add it in. So notice we pass in our dictionary of rendering information into here. We're going to say that we want to normalize by the field, and our normalization field is pop 2015. So let's see how this looks. Let's go ahead and run it. Now we get our point data and we see various colors, but we don't know what they are, so we can take advantage of the legend again. And we can see our comparison has shown. So we're going to compare our pop 25 divided by pop 2015. We have our percentages and the various color breaks that we set up here. And this was all defined for each one of these stops. We could also do this information and have the point symbols adjust by size as well. And there's a few other ways. And all this information about Arcade can be found on developers.arcgis.com. And you can go ahead and explore all the different ways you can take advantage of the the visualization language of Arcade to create really expressive and very dynamic base cartography. So it's pretty, you can do some really powerful things. Let's take a look at another way we can do this. We're going to do another class, a simpler class break renderer. We're going to just set our field for our feature layer and then just show it on the map. This is just another expression of how we can show information and how fast it reacts when we say that this is the type of renderer that we want. So before, when we did this type of class break renderer above, we used that query definition and just cut out the state of Washington. Now we have the whole continental United States and everything's being rendered on the fly for us. Another part of visualization is using spatial-enabled data frames. And spatial-enabled data frames has that plot method, and we saw that before. And this is going to allow us to follow the syntax of matplotlib to do visualizations on the map. We can leverage a lot of the stuff we learned before to quickly make very complex and visually appealing cartography. And some of the advantages of doing that using the spatial-enabled data frame is that it's Pythonic. If you're familiar with charting within pandas and matplotlib, it's the same thing. And it can work with multiple attributes at the same time. So you have all the features that you have by rendering using smart mapping, you can control it all on the spatial-enabled data frame. It supports simple, unique with Arcade, class breaks, and heat map. Let's go ahead and obtain some information first. So we're going to obtain data from this item, and it's going to have population data, and we're going to have our point locations for various cities. And we're going to go ahead and look at the first 5 records in our pandas data frame. We can go ahead and let's use a unique renderer. I'm going to set some properties on it. I'm going to say find Reno, Nevada, then zoom out to level 4. Here's my center coordinates, and then show the map. So we have our default map, and basically I was centering to the center of United States. Okay. We're going to do stf.spatial.plot. This is going to allow us to draw our map, specify the map widget that we want, the type of renderer, which is a unique renderer, and then the column we're going to render on, which is state name. So here we have all of our locations rendered. Each state has a unique name, has a unique color. We can do simple rendering. So this is simple rendering allows us to take points, lines, and polygons, and do simple renders on it, such as simple lines, simple polygon fills, and also simple point locations. Notice in this case, instead of having our traditional circle, we set the symbol style to D, so that means diamond. We specified a color ramp, red in reverse, and we specified the color red, the step we wanted. Same with our outline color, and then we set the marker size to 10. And a lot of this should be very familiar if you've ever made graphs within Matplotlib or the other graphing libraries. So the syntax is actually very similar. Here's using a class break render. In this case, we're going to specify an arbitrary number of classes, the column, a color map, and our alpha, which is our transparency. And as we zoom in, we can see the various colors. So here's one down here, and we can see all the information is populated. But so a lot of the stuff that we've seen, I've been referencing color maps here. But how do you know what these color maps are and what they look like? Well, we have helper functions, so we can do from ArcGIS.mapping, import display map colors. Then we can call the function display map colors. And this gives us a rich visualization of every one of those color maps that we had. And there's quite a few, about 110, I believe, out of the box. And the other thing we can do is for all those symbols that we're referencing, maybe you don't know what all those symbols are or what those colors are. So we can also visualize it with the name-wise. So if we want to copy and paste them, here's another way we can do it. And if let me insert another row below. And we can also take this symbol here and we can create our own symbols as well. So if we take a look at this function, we can see that we can pass in our geometry type, the symbol and colors, and it'll spit out that JSON that we had. And we can see that it shows us what each which each simple symbol should be for points, polylines, and polygons. And notice that besides solid colors for polygons, you can use backwards diagonals, forward diagonals, the vertical, horizontal, cross, and it's all represented by just putting in a plus or an X. And the same thing for polyline. Besides solid, you can do dash, dash dot, and all the other ones that are supported within there. So that rich symbolization that you have in ArcGIS Pro, you can pass it on to your web maps and have it be very, have the symbols match very closely. Here's a demo that I wanted to go right into, and this is another demo just working with the map widget. So we're going to go ahead and connect to our GIS. In this case, I'm going to connect using an account I have, leveraging profiles. We're going to go ahead and search for Ebola maps. And this is a project that I actually worked on a few years ago. And we want to look at Ebola incidences and facilities. I need to make an update. So I have this existing web map. And the question is how can I take this information, add the missing layer to it, and then save it back to our web, to my enterprise. So I'm going to do from ArcGIS.mapping import web map, and this will give me a web map class. Let's go ahead and import it. I'm going to take the layer, I'm going to take the web map that I currently have, which is the third one in my web maps, and grab it. And we can go ahead and display it on the display it just to see what we have. Notice I'm using OpenStreetMaps coupled with a whole bunch of other layers. I can zoom in and out, and the map will be responsive, and the symbology will update as designed. I'm going to visually make sure that see if my layer is there. And the layer I want to add is not there yet. So I'm going to go ahead and take my item, because I know the ID, get it by doing gis.content.get, add it to my map, and this will add my layer in. We have it here. Now that I have this information, I can go ahead and I can update some item properties. So I have new layer, Ebola incident facility. And I just take webmap.save and pass in those properties, and it'll create my new web map here. I could also persist the information out by doing a save without updating any of these properties, and it should overwrite the existing web map that I have doing an item.update, I'm sorry. And it'll overwrite the existing one. But in this case, I wanted to make a secondary copy and save it to my organization. So that's just a quick way we can go ahead and work with web maps and do visualization. If you have any questions, please post to the forum.